These are our chapter 9.5 notes, solving trigonometric equations, page 7. And so we're going to take a look at things a little bit differently because, I haven't given you enough to think about already. We are going to solve trig equations with multiple angles. So let's take a look at example 16. We want solutions on the unit circle, 0 to 2 pi, of cosine 2x equals 1/2. Now I could use a double angle formula, but I would end up with either cosine squared x's and sine squared x's or one of the two, and that doesn't feel like it really helps. So I'm going to go ahead and substitute in for the 2x for a minute, and I'm going to say, I'm going to call it alpha. Cosine alpha equals 1/2. I know that that is true when alpha is pi over 3 in quadrant 1, or 5 pi over 3 quadrant 4. Cosine is positive in quadrants 1 and 4, so I'm pulling out those quadrant 1 and 4 angles. So alpha was really 2x. So I can go 2x equals pi over 3, divide both sides by 2 so I can solve for x. I get x equals pi over 6. I get 2x equals 5 pi over 3. Again, I'm going to divide both sides by 2. I get x equals 5 pi over 6. And that is pretty straightforward, but feels a little funny because when I divided my angle there by 2, when I took my 2x and divide by 2, I kind of feel like I'm cutting my circle, my 2 pi, in half. And both of these solutions lie between 0 and 1 pi, which makes me a little worried. So I'm going to see what happens if I go around that circle one more time, just to see if I end up with an angle that still falls between 0 and 2 pi. Okay, so my 2x, I'm going to start with my first angle, that pi over 3. I'm going to add 2 pi to it. I get pi over 3 plus 2 pi, so pi over 3 plus 6 pi over 3, that gives me 7 pi over 3. If I divide both sides by 2, I get x equals 7 pi over 6. And you know what? That is an angle that falls between my 0 and 2 pi. So I know that if I multiply that by 2, I get 7 pi over 3, which is coterminal with pi over 3. So 7 pi over 3 actually works. Okay, I'm going to go ahead and see what happens if I go around that circle one more time. I got 7 pi over 3 plus another 2 pi. So this is coterminal with 13 pi over 3. If I divide both sides by 2, I get x equals 13 pi over 6. Well, 12 pi over 6 is 2 pi, so this one's too big. So even though my 7 pi over 6 works, 13 pi over 6 does not, because it falls outside this 0 to 2 pi interval that I have to work with. Okay. So it makes sense. 2 times x went twice around the circle, divided by 2, and got 2 different angles that satisfy this equation. Okay, so I need to do the same thing with my 5 pi over 3. So I got 2x equals 5 pi over 3. I'm adding 2 pi to that to find a coterminal angle. So I get 5 pi over 3 plus 6 pi over 3. Gives me 11 pi over 3. When I divide both sides by 2, I get 1x equals 11 pi over 6. That is still less than 2 pi. So this one works. Okay, just so we're consistent with what we did before, I'm going to go around one more time. I got 11 pi over 3 plus another 2 pi, so plus 6 pi over 3 gives me a 17 pi over 3, which means that x would be 17 pi over 6, which is also bigger than 2 pi. So once I find those original angles, I'm going to add 1 unit circle to them, that 2 pi, to get a coterminal circle that is 1 more rotation. We divide by 2, and then all of those angles lie within that 0 to 2 pi range. So my solutions are actually pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay, so let's take a look at example 17. Notice here that I have got cosine 6x and cosine 3x, and those have 2 different arguments, so I can't combine them at all. I can think of cosine 6x as a double angle, 2 times 3x, and then I'm going to pick the version of my cosine double angle formula that I think is going to be most useful. I still have that cosine 3x in here. That's not going away. So I want to be able to write this in terms of just cosines. So that's 2 cosine squared 3x minus 1. Okay. So in my equation, I'm replacing my cosine 6x. Let me rewrite the equation so you can see fairly easily what I'm replacing. I got cosine 6x minus cosine 3x equals 0. This is being replaced with my 2 cosine squared 3x minus, I'm going to go ahead and write in descending order. I'm going to stick my cosine 3x before my minus 1. And now I'm going to factor. I got 2 cosine 3x. Hoping this factors because the thought of the quadratic formula here does not make me happy. The only way to get 1 is 1 and 1. I need to end up with a negative cosine 3x, which means my negative 2 cosine 3x has to be, sorry, my 2 cosine 3x has to be negative. My 1 cosine 3x has to be positive. And so I end up with cosine 3x equals negative 1/2. And cosine 3x equals positive 1. So let's see, cosine at 0 is 1. So 3x equals 0. Divide both sides by 3, and I get x equals 0. Again, feels a little sketchy, so I'm going to go ahead and add 2 pi to that. So I get 3x equals 2 pi, x equals 2 pi over 3. And that's still between 0 and 2 pi. I'm going to add 2 pi again. And I get 3x equals 4 pi. Divide both sides by 3, I get x equals 4 pi over 3. If I add 2x again, I'm going to get 6 pi, which is divided by 3 gives me a 2 pi. Let's just go ahead and do that. Sorry, 4 pi. There's my 4 pi plus 2 more pi equals 6 pi. When I divide that by 3, I get 2 pi, and that is out of my interval. So I'm not worried about that one. Notice I did the easy one first because that kind of makes me happy. And so now I'm going to go ahead and we're going to take this little lovely, and I'm going to go ahead and see if I can do all the work over here. So where is cosine negative 1/2? So cosine is negative 1/2 at 2 pi over 3. And cosine is negative 1/2 at 4 pi over 3. The 2 pi over 3 is in the second quadrant. The 4 pi over 3 is in the third quadrant. Okay, I'm good. And so x equals, divide both sides by 3, I get 2 pi over 9. And I get x equals 4 pi over 9. Awesome. But it still feels like I'm using only a little bit of our unit circle. So now I'm going to go back to what we just did. If my 3x equals 2 pi over 3, I can add 2 pi to that. I get 2 pi over 3 plus 6 pi over 3. That gives me 8 pi over 3, which when I divide both sides by 3, I get x equals 8 pi over 9. Okay, so let's do that again. I got 3x equals, where am I? 8 pi over 3. You notice I'm adding this to the angle. I'm finding a coterminal angle before I divide by 3. So what I'm doing is I'm wrapping that original angle. I'm adding 2 pi to that to wrap around the circle one more time before I divide by 3. Okay, so plus 2 pi. So that gives me 14 pi over 3. When I divide both sides by 3, I get x equals 14 pi over 9. See, 18 pi over 9 would be 2 pi, so 14 pi over 9 is still within that interval. It's less than 2 pi. Keep in mind, if I wrap around one more time, I'm going to get 14 pi plus 6 pi, 20 pi over 3. That's going to be too big. So I can wrap around the angle 2 more times, a total of 3 times, which makes sense because it's 3 times x. If I go that 4th time, I'm going to have an angle that's too big. It does not lie in my 0 to 2 pi anymore. So we've got multiples of this one. Okay, let's try our 4 pi over 3. So I got 3x, now 4 pi over 3 plus 2 pi. So 4 pi over 3 plus 6 pi over 3 gives me a 10 pi over 3, which when I divide both sides by 3, I get 10 pi over 9. Just a little bigger than 1 pi, so definitely less than 2 pi. And then we're going to do this again. 3x equals 10 pi over 3 plus 2 pi. That gives me 16 pi over 3. When I divide both sides by 3, I get 16 pi over 9. Both of those are less than 2 pi, and that takes care of this angle. And so let's see what we got here. Box is too big. So I've got x equals, I can put them in numerical order. 0. I got 2 pi over 9. Yeah, you know what? I don't think that hard. So let's do 0, 2 pi over 3, and 4 pi over 3 together. I get 2 pi over 9, 8 pi over 9, 14 pi over 9, and then I've got 4 pi over 9, 10 pi over 9, and 16 pi over 9. So you'll notice for this one, I did go into Desmos, and I've added this graph here for you. The red graph is our y equal cosine 6x minus 3x minus cosine 3x. The x-axis is that y equals 0 part, so there's the other side. You'll notice it crosses at 0. Here's my 2 pi over 3. Here's my 4 pi over 3. The next time we get that little bump here is at 2 pi, which is the same as 0, so we have not included that as a solution because that's not part of our interval. And then you've noticed I've got this counting by pi over 9s. Here's our 2 pi over 9. Here is our 8 pi over 9. Here is our 14 pi over 9. And I might as well go backwards now. 16 pi over 9. Here's my 10 pi over 9. And here's my 4 pi over 9. So if you are going to Desmos to graph, you will see the little wrench up in the right-hand corner. And that gives you the opportunity in upper right to change your axes. So pretty easy in Desmos. If you want pi, you literally just have to type in pi, P-I, and it will change it to a pi for you. I can change the limits on my x and y axis. I can also change what it's counting by. So here for my x, I went 0 to 2 pi because that's the interval that I'm interested in. My y, I went from -2 to 3. And then my step along the x, I had it listed as pi divided by 9. So it was hitting all of those values that I wanted it to hit. And that's page 7.